Hi everyone. In this video, we will be talking about finding extrema, specifically finding absolute extrema using the second derivative test. So if you're interested in seeing how to find relative extrema or how to find absolute extrema using the first derivative test, you can find those videos where you found this one. So for now, we're going to just go straight down to the example where we find extrema using the second derivative test. So remember that our first step to find absolute extrema or any extrema is to always find the critical points of the function by finding when the derivative is 0. So if our function is x to the fourth minus 2x squared plus 3, then we find the derivative term by term by applying the power rule. And after we do that, we set that derivative equal to 0. And so in order to find x here, we are going to factor this. So the first thing that we look for in factoring is finding a common term. And once we do that, we see that we're left with x squared minus 0, which is a difference of squares, so we factor that. At this point, we are going to apply the zero product property, which you may or may not have heard of, but all it means is that each part that multiplies to equal 0, we individually set those factors equal to 0. Now we have these three equations, and we solve them each separately for x, getting x equals 0, 1, and negative 1. So these are going to be our critical points, which are our candidates for the extrema of a function. So I'm just going to take a second and point out something that we want to avoid whenever we are solving this equation. So one thing that we don't want to do, it may have been your first inclination whenever you saw the equation 4x cubed minus 4x equals 0, you may have said, okay, well, why can't I just add the 4x to both sides? And then I see that I can divide both sides by 4x. And whenever you do that, you're going to be left with an x squared equal to 1. Then you can apply the square root to both sides and get x equals plus and minus 1. So like I said, we don't want to do this because when we compare what we just wrote to the black text on the left of it, we see we forgot somehow we didn't get the solution x equals 0. And that's because this dividing by 4x got rid of that solution. So if you see that your terms have something in common and you want to rewrite this equation so we can divide it from both sides, that's an indicator to you that that's actually a common term that you need to factor out. So just keep in mind, we never want to divide whenever we're setting things equal to 0 because it can get rid of one of our solutions. So now that we have our critical points, because we are specifically using the second derivative test, we want to compute the second derivative. So the second derivative is the derivative of our derivative. So again, we use the product rule to take the derivative term by term and get 12x squared minus 4. So now, again, because we're using the second derivative test, we are going to evaluate the second derivative at each of our critical points because the second derivative tells us if the function is concave up or concave down. So I'm evaluating my second derivative at my critical points. So I'm going to start with 0. So 12 times 0 squared minus 4 is 0 minus 4 equals negative 4. My second derivative at 1 is 12 times 1 squared minus 4, which is 12 minus 4, which is 8. And lastly, at negative 1, I have 12 times negative 1 squared minus 4, which is 12 minus 4, which is 8. So just like with the first derivative test, we can determine, we need to figure out, are these positive or negative, because that's going to tell us is our function concave up or concave down. So once I figure out the sign of these, I like to draw what the function would look like. So here my function is concave down, here my function is concave up, and here my function is concave up again. So we can immediately use this concavity to tell if we have a minimum or a maximum. And I like to draw this because it helps me figure out, okay, is that point right there a minimum or a maximum? So the function is concave down at x equals 0. So that tells us that this is a maximum. So this is a little bit tricky to remember that concave down is a maximum, but that's why I would suggest just drawing a little sketch of concave down means the point is at the top. Next, the function is up equals 1 and negative 1. So these are minimums. And again, we can see that from our little sketch. Sorry. And this last part, there is no critical point where the function is neither concave up or concave down, so there's nothing to write here. So if our second derivative was equal to 0, we wouldn't know the concavity of the function at that point, and we would not be able to tell if it was a maximum or a minimum. Okay, so for the second derivative test, we find the critical points, evaluate the second derivative at those critical points, and that's all. The concavity immediately tells us if we have a maximum or a minimum. So like I said, this was just using the second derivative test. So if you want to watch a video on how to find relative extrema or how to find absolute extrema using the first derivative test, you can find those videos where you found this one. So that's going to be all for this video. We hope this helps, and good luck.